Okay, so let's say we have the graph of f, and we want to figure out what the graph of f prime would look like, the first derivative, or f prime prime, the second derivative. This is climb time, and in this video, we'll look at derivatives and their graphs. All right, so let's say we have this graph right here, and I'm looking at A, B, C, D, and E, 5 points, 1, 2, 3, 4, 5. And I want to sort of analyze and say, what is the meaning of f prime, and f prime prime? And what do I know at these points, A, B, C, D, and E, in terms of f prime, and f prime prime? So f is going to be the y values. That's what the meaning of f is. It's the y values of our graph. So we look at our graph, all the y values is what f represents. F of x is the output or the y values. So if I look at A, I can see that A is positive because it is above the x-axis. So I'm just going to say greater than 0. If I look at B, B is also positive because it's above the x-axis. So this is also greater than 0. If I look at C, C is on the x-axis. So I'd say C is equal to 0. D is right here. It's below the x-axis, so it would be less than 0. And then finally, E is on the x-axis again, so it's equal to 0. So this is something we learned when we learn about functions, and we learn about the output of functions and how they're equal to y values. And we understand the y values are positive when they're above the x-axis, negative when they're below the x-axis, and 0 when they're on the x-axis. So that would be f. Now let's look at f prime, which is the first derivative. So you know what might be helpful is if I actually put like a little color box around f to say f is the green part. Okay, now f prime is the first derivative, and that is the slopes. So I'm going to say slopes here. Slopes. So f prime is the slopes. I'm just going to make this orange to kind of keep that associated with slopes. All right, so f prime is the slopes of this graph. So I look at A, the slope here is going to be positive because it's going up. I'm reading left to right, it's going to be positive, so it's greater than 0. At B, the slope is flat. So that means it's equal to 0. At C, we're going downhill, and that makes the slope negative. And at D, again, it's going to be flat again because this is kind of like at the bottom of a little dip here. And so the slope of the tangent line should be 0 there. That's what I'm trying to show by having it at the bottom there. And then E, I'm going uphill again, and so my slope is greater than 0. So we want to be able to keep this separate. F, which is the y values, from f prime, which is the slopes of f, from f prime prime. And so we'll look at f prime prime last. So f is the y values, f prime is the slopes. And you can see there's some similarities. There are times when they're both positive, but there's a lot of differences too. So they're both positive right here because both the y value is positive and the slope is positive right there. But I think that's the only time when they were the same thing. So let's look at f prime prime now. And so I'm going to make this one pink. And f prime prime, as we learned in another video, is concavity. And so if you want to learn more about concavity, check that other video out. So concavity. And so what we learned in the video on concavity is when you have something that's upside down like that, it's kind of like an upside down bowl, then it's concave down, and the second derivative is negative. When it's a bowl that's facing up like that, it's concave up. So when the graph is kind of frowning, it's concave down. When it's smiling, it's concave up. So that means that A, it's concave down. It's negative. At B, it's still concave down because the concavity is still concave down in this spot. And so B is actually also negative. At C is possibly the point where it switches from concave down to concave up. And so I'm going to say equals 0 here because I think it's switching concavity there. At D, it's part of this bowl that's facing up. So therefore, it is now concave up, which means it's greater than 0. And then finally at E, it's also part of this bowl where it's concave up, so it's greater than 0. So there's the differences between y values slopes and concavity, the difference between f, f prime, and f prime prime. Sometimes they line up and sometimes they don't. You can see f prime and f prime prime lined up at E because E was both increasing, so therefore the slope of the tangent line is positive, and it was also concave up. And so therefore they're both greater than zero at that spot. So there are some patterns there for sure, but make sure you keep y values, slopes, and concavity separate because they are different things as they're related to the F graph. And this graph here is the F graph. And so therefore the y values of the F graph are here. And the slopes on the F graph are the F prime. And then the concavity would be the last part. So I think I might actually just show the concavity like this. Okay, and you can see that there it's the bowl is facing down, and here the bowl is facing up. All right, and there's a concavity. All right, so that is taking a look at the different derivatives and how they're related to the original graph. And now we want to go back to our original question is, I have a graph of f, how do I graph f prime? All right, so what I want to do is I want to look at, I think the key here is to look at where the zeros are. Everything sort of revolves around the zeros. Because if you look at what we have here, we have positive, we have negative, we have zero. And zero is usually where things switch between positive and negative. It's hard to get from positive to negative without going through zero. And so zero is sort of like this critical point that helps us to see what's going on. So what I want to look at is where the slope is zero. So the slope is zero here, and the slope is zero here. And so that is going to be the spot where I can identify a y value for f prime. So where the slope is zero on f is going to be the y value for f prime. So that means f prime is going to have a zero y value here and a zero y value here. Okay, so that means it's going to go through the x-axis here and here because that's where the slope of f is zero. The slope of f is zero here, so therefore the y value of f prime will be zero at that same spot. The slope is zero here for f, so therefore the y value of f prime will be zero there. So now we know where it goes through the x-axis. So that's really the starting point. Where is the slope equal to zero? That's where you're going to go through the x-axis for f prime. Now, it's the only place where I can cross the x-axis. Now, what's happening between these two zeros? So if you look at f, what's happening is the slopes are negative. It's going downhill. So because the slopes are negative, that means the y values for f prime have to also be negative. So what it's going to look like is something like this. It's going to come up like this. Okay, so f prime is basically going to only cross the x-axis here and here because those are the only two spots where the slope is zero on f. And it's going to have negative y values where f has negative slopes. It's going to have positive y values where f has positive slopes. So f has positive slopes here, f has positive slopes here, and so this has positive y values. So these y values are associated with these slopes. So a slope over here would be associated with a positive y value here because it's going uphill. So it's going uphill, the slopes are positive, so therefore the y values are positive. Where it is got a slope of zero, it's got a y value of zero. So between these two zeros, the f has negative slopes, so therefore f prime has negative y values. So that's how you get from f to f prime. Now to get to f prime prime, you do the same thing basically, you just do it on f prime. So you ask yourself, where is the slope equal to zero on f prime? And if you can figure out where the slope is equal to zero on f prime, it's right here. That's where you're going to have a zero y value for f prime prime. So right here, the slope is zero. So therefore on f prime prime, a y value would be zero. So again, you look at the slopes on f prime to find the y values on f prime prime. And so 0, 0. So now you can see right here, the slopes are negative. I'm looking at f prime only right now. The slopes are negative on f prime. And so therefore the y values on f prime prime have to be negative. So the negative slopes here on the orange one are associated with the negative y values here on the pink one. And as you can maybe imagine, and then again, I'm looking at the orange one to make the pink one. And so in the orange one, I have slopes that are positive. Therefore, I have y values that are positive. But what helps you draw the lines is the zeros. Start with the zeros. So from f, I have, of course, I have the zeros of f, which are where f crosses the x-axis. That's not helpful for drawing f prime, actually, but it's helpful to know that the zeros on f are here, here, and here. But what's helpful to draw f prime, the graph of the derivatives, is knowing where the slopes are zero on f. The slopes are zero here and here. So therefore, f prime, which is the orange one, will have y values of zero here and here. So there is a connection between a zero y value, a zero slope and a zero y value on f prime. So a zero slope on f is a zero y value on f prime. A zero slope on f is a zero y value on f prime. And so once you know where the zeros are, where across the x-axis, you kind of figure out where is it negative and where is it positive. And where it's negative is where f is going downhill. Where it's positive is where f is going uphill. So everywhere to the right of this line, f is going uphill, and the y values of f prime are positive. Everywhere to the left of this line, f is going uphill, and therefore the y values of f prime are positive. So uphill means positive slopes. Again, reading left to right. Uphill means positive slopes, which means positive y values on f prime. And the same process is applied between f prime and f prime prime. So if we can understand how to get from f to f prime, we can also understand how to get from f prime to f prime prime because it's the same process. Now we can kind of go back and check ourselves a little bit here and say, does concavity line up? So where f prime prime is zero, do we have a potential inflection point? And it looks like we do because this looks like it's concave down and this looks like it's concave up. So it looks like where f prime prime is zero, we do in fact have an inflection point. And where the y values are f prime prime are negative, do we have a concave down on f? The answer is yes. F is concave down where f prime prime has negative y values. And then also in the same way where f prime prime has positive y values, f is concave up. So f is concave up when f prime prime has positive values, and f is concave down where f prime prime has negative y values. And then when f prime prime is zero, it looks like an inflection point where it switches from concave down to concave up. Okay, so that's how you draw a derivative graph from the original function graph. And that's how f prime, and f prime prime are related to each other in terms of slopes and concavity.